Welcome everyone to this workshop of Coordinate Your Automations with Durable Execution. My name is Mason Egger, and I will be coming to you from Austin, Texas today, where it is hot, but I'm also a native Texan, so it is normal for me. So like it's gonna be like in the low. Actually, it's gonna be kind of cool today for June. It's gonna be like in the low 90s. That's kind of cool for June, considering. So, let's go ahead and get started. So, my name is Mason. I'm a developer educator at Temporal. I'm a programmer. Prior to going into developer education and developer relations stuff, I was an SRE. I got paged one too many times, and now I do this for a living because no one pages you when the docs go down. It's great. I do enjoy teaching. I've taught quite a bit, so this is always fun stuff for me to do. I write on my blog, working on a couple of books. And I'm a community organizer of PyTexas. So if any of you are in the Python community and you're ever looking for another regional Python conference to come visit, come check out PyTexas. We'll be next spring and it'll be our 20th year. So that's a lot of fun. So what are we going to cover today? Today, we're going to build a durable CI/CD pipeline. So I'm going to go through and teach you about Temporal. And we're going to do this by doing a use case-based scenario. We're going to build a CI/CD pipeline. The title of this was Coordinate Your Automations, which was intentionally vague because I did not know what I wanted to do whenever I wrote the abstract. But CI/CD pipelines are something that I've always been super fond of and worked with a lot whenever I was still working in a production code base. So I very much enjoy talking about them, and Temporal adds a lot of really neat features to them. We're going to explore how Temporal provides durable execution to these, and we're going to implement various features such as human in the loop, durable timers, and even some polyglot features as well. So before we get going, I'm going to go ahead and do a quick brief intro of what Temporal is, if you've never heard of it, and then we'll move on. So Temporal is an open source durable execution platform. Basically, that we have a lot of different ways of explaining it, but durable execution is what we're calling crash-proof execution. So what this means is that crashes, failures, things that happen with your application, they can still happen, but they're inconsequential because Temporal handles them and either retries it until the maybe say like a microservice goes down and we retry it until eventually it becomes relevant, like up and works again. Or say you lose a a Kubernetes pod and it had like in the middle of an execution, we will repopulate the state of your application onto another execution and continue on as if that never happened. So we like talking about it as if basically failure is inconsequential, or reliability, resiliency as a service, kind of one of the little buzzwords we've been using lately. But what it allows you to do basically is, instead of you as the developer having to focus on all the complexities of error handling, it allows you to focus on the core logic of the application and not really worry about it quite so much. So it's a really neat little thing. So some of the benefits of Temporal, basically it does abstract away all the complexities around retries, rollbacks, queues, state machines, timers, all of this kind of stuff that normally you as the developer would have to spend your time figuring out, or like writing code for. Essentially, you would like there's a lot of boilerplate code out there that handles all of this. Um, and it's like, honestly, there's probably more boilerplate than there is actual core business logic most of the time, because we have to think of all the different ways things are going to fail. So Temporal abstracts this away. And then the interesting thing about Temporal, and one of the awesome things, is Temporal is a code first platform. So there are a few other things that provide this kind of durability, but they tend to be like wrapped in a DSL, or they're severely limited, or they're in expressed as like a YAML format or something. Temporal is programming first. So you write it in the programming language of your choice. And these programming languages have SDKs that are idiomatic to the language. And that's super important because our SDK engineers spend a lot of time making this really easy to understand for people who are familiar with the language. And that's one of my favorite features about it, is that like whenever I'm writing Python workflows and such, it looks and feels like I'm writing real Python. And that's really awesome. And then you deploy and run your code in your environment. Temporal is, like I said, it's open source. Even if you were to use the cloud offering, you still are responsible for running your code. The Temporal open source cloud offering is literally just the orchestrator. It's not the execution platform. That still runs in yours. So basically, you never have to worry about Do I have to ship my data off site? Do I have to, spin up in a cloud that I'm not familiar with? Can I do this on-prem? Yes, yes, yes. All of these things. You don't have to worry about any of these issues because you control the execution environment. Um, and basically, Temporal provides a fault-tolerant durability layer so you can recover from failures as they happen. So, what are we actually going to build today? So, we're going to build a CI/CD pipeline that has a couple of characteristics, and it's going to go start to end. The phase one we're going to do is it's going to build a container. So, we're going to build a container, test a container, upload it to a container registry to kind of show you the core primitives of Temporal. Next, we're going to deploy it to Kubernetes into a staging and production environment. So we're going to deploy it in, and we're going to have a little bit of like human in the loop stuff here. So essentially, like we're going to deploy it into staging, and then it's going to sit there and await approval from someone. And then once it's approved, we'll deploy it into production. And then the last part of this will basically, if it is not verified at the very end, like if we don't verify that yes, this did in fact work, it will automatically roll back for us. And we're going to see all of this built with native temporal features. You don't have to build it with, some weird pipeline DSL or something, all code based. And if you would like to if you would like to follow along with the code, there is a GitHub repository which I will drop in the chat. Um, so you will be able to do that if you would like. And what there are is there's 4 different branches in this GitHub repository, which I'll just go ahead and show you now. There's no reason not to. So there's a main README that has everything in it and how it works. If you scroll ahead, you're going to spoil the fun, so it's up to you if you want to, spoil all the fun stuff we're going to do. But we have 4 branches that basically have the code. This is all written in Go, because platform engineers love Go. I would have written it in Python, but that's just me because I love Python. I mean, if I was building this in real life, I'd write it in Go because that's just typically what you write this kind of tooling in. But there's 4 different parts that we're going to go through as we build it, and to kind of show you a diagram of what we're going to do. And unfortunately, this diagram is huge. Like I tried to put it in my slides, and I just could not make it like fit. So, and I didn't have time to make it look better because I used Mermaid for this, and then that didn't. It imported into Excalidraw fine, but didn't format the way I wanted it. So we're basically going to start our pipeline. We're going to build a pipeline, or sorry, we're going to build the Docker image. We're going to test the image, push to the registry. That's part 1. Then we're going to check and see if the environment is either staging or production. Well, actually, technically, we're deploying it to staging regardless. And then we're going to check if it's production. If it is production, great. We're going to go through a whole other process. If it's not, we're going to end it right there. We're going to send an approval request. We're going to wait for the approval signal. If it's approved, we're going to reject it. So we're just not going to deploy it into production. If it is approved, we're going to deploy it into our production Kubernetes namespace. And then we're going to start this is basically the human in the loop section. And then the final section is starting a validation timer. So essentially there'll be like a 30, you would normally set this for longer, but for demo purposes, I've set it to 30 seconds. Basically, if no one validates that this deployment to production did not break all of production within 30 seconds, essentially it will automatically roll itself back and remove itself from the cluster. And that's essentially what we do. And then part 4 is kind of a fun little surprise part. So if you have any questions during this, please ask in the chat. I'm keeping a diligent eye on the chat, so you're always welcome to ask any questions you want. You don't have to wait for me to get to a stopping point to ask the question. I like answering questions in the context in which we're talking, because if we move on, then the question may not be relevant anymore. So ask them as soon as you have them. I will always try to come to the quickest stopping point that I can to answer your questions. So from there, we're basically going to do a whole bunch of live coding or live executing. The code is already written. And as I said, you have the GitHub repository there that you can follow along with. And am I forgetting anything? Oh, just for simplicity's sake, I am currently hosting my Docker container registry and my Kubernetes sources on DigitalOcean. I worked there in the past, so I know exactly how to do this really fast and didn't have to put that much effort into spinning them up. But they support anything you want to do. So if we're ready, if there's no objections, we'll start with part 1, which is building our container. What I'm going to do is I'm going to actually demo these first few parts, and we're not going to really look at the code yet, or we're not going to talk about how it's built. So part 1 and part 2, as you can probably see from my screen, we're going to talk about like what is actually happening under the hood. We're going to go through it, and then we're going to come back and talk about the primitives and implement the last parts. So let's go ahead and move over to part 1. So I need to change branches. Git checkout, part 1, Docker pipeline. Okay, so the first thing I'm going to do is I'm going to actually run the temporal server in developer mode. So there's a local CLI tool that you can use if you're using a Mac, brew install temporal IO, or maybe it's brew install temporal. I never remember actually. I think it's brew install temporal. I think temporal IO is the name of the Python package. Let me check real quick. It's brew install temporal. I'm thinking temporal IO because I'm thinking of the Python package. So you install temporal, the local development CLI here. And basically now if we go to localhost port 8233, we now have our temporal service running. So the temporal service consists of a whole bunch of backend services that orchestrate all of your executions. And then we have our front end service, which basically gives you visibility into this. So what we've done is we've built out our pipeline. Where's my VS Code? There it is. Using what are called workflows, activities, and that's pretty much it for now. And again, I'm going to get into what this core stuff is later. But what we're going to do is we're going to just go ahead and see what it does. So the one thing that you have to do when you run temporal is you have to run kind of like what's called a worker, or it's kind of like the temporal model is a server worker model. So you essentially have this fleet of workers that executes the tasks and this orchestrator that basically makes sure that they execute in the order that you want them to. So we're going to go ahead and run workers main.go. That will start our worker. And now I'm going to just go through my old commands and make sure I have the right one because I don't want to have to. It's not the ones that don't have action. There it is, image. So what we're going to do is we're going to create a demo app. I'm actually going to come back. I'm going to change the tag image. We're going to go to 3.0 on for the actual live demo of this. We're going to create a demo application with a tag 3.0 sample Docker file in the registry. And the registry is my container registry. Now the sample app is relatively straightforward. I mean, it's a hello world app. So it has a health check endpoint, and it has a hello world from Temporal CI/CD workshop running on hostname. This whole running on hostname thing is useful for us because essentially whenever we start deploying and staging in production, it will at least show us that the deployments are different because it'll have a random hostname ID. So let's go ahead and click run, start running this. I did not have the right command. Of course I didn't. If I have to, I'll go to the README, but I'd rather find the right one. Come on. This should be this one. Okay, so now we have requested the execution of a workflow. Our code returns immediately, or our request. Oh, it failed. Great. What did it fail for? Ooh, the endpoint testing isn't working. Why is it trying to check across 32851? That's odd. We seem to have broken the test on this. That's great. If I have to, I'll remove that activity from the workflow code, but it's odd because I literally tested this 5 minutes ago. You know what? Let's check. Git checkout part 2. We can just go to part 2. Of course, law of live demos always breaks whenever you expect it not to, even if you test the darn thing a minute ago. Okay, so this one actually does need the create function. If this one fails, we're going to have a bad day. It's not failing. Good. So this is what it should have done. I must have broke it in the first one, which is funny that the advanced ones work, but the first one doesn't. So what we're doing now, and I'm actually we are building our Docker image. We are then, and what we can see here is we built the Docker image. We are testing our Docker container, which this did work on this side. So I have to figure out why on earth it decided to pick a random port. And now it's pushing it to the container registry. So this is the interesting part, is that whenever you're running temporal, everything that you have, all the methods that you call, basically get saved as events in the event history. And what I can see now, if I scroll down, is I can actually dig into all of these. So like we have our workflow execution started. This is actually the input that I had whenever I originally started this application. Yes. I see. And now we have that running, and then we have our activity task started, which you can see the input, and once it gets to completed, so we can actually see the output. So we can see the image and the build time that it was built. We can then go and check and dig into each and every one of these and see, what was the input and output of my request. So this is really useful for introspection into what we're doing. So we're building a Docker push. We've now pushed to the registry. And this one, because we had to skip past one, we immediately are deploying into our Kubernetes service. So now we have this application deploying into Kubernetes and it's sitting in staging. So if I take my URL and I go here, we see that we get our application. So it is running on a live on a live URL. So essentially what we have here is we have a lot of like really good observability tooling that Temporal offers you by default. Now let's try doing something a little bit neat. Um, and let's see what happens if something were to like fail or something. Actually, what I didn't do here is I didn't do the environment section, or I didn't do the set the environment variable correctly, or the environment flag to deploy it into production. So if we look back at my command, we are only currently running this and deploying it into staging. So now we have our container deployed into staging. We have our inputs and our outputs, and we basically have all this introspection in now. And what we've done is we've orchestrated this in a durable way. So the interesting thing that I could do here is I could actually kill that one worker, which is running over here on the side. And as you can see, this was all the logs for everything that was happening during its execution. I could kill this worker during one of these deployment phases, and it would automatically recover from it. So let's go ahead and demonstrate that durability. And do I want to do, they're going to actually, no, I was going to do that into prod, but I hit the wrong button. So um, we'll just let that one go. And we'll try killing it, the push to the registry. Let's see if that works. So we killed the worker. Um, I think the issue is I think I have my start timeout. Yeah, my start to close timeout on these is way too large. So this was a bad example to do this with. Because it's 10 minutes. So essentially, after 10 minutes, what will happen is that Temporal will detect that this has not completed and it will retry the deploy again. I have that set to way too large in my workflow code because this is me when I was testing. So currently, what it will do, we're not going to sit here for 10 minutes and wait for this thing to turn like fail. But essentially what will happen now is there's nothing happened and there's nothing running, but after 10 minutes it would automatically have failed, and then it would have been rescheduled on another available worker, which would have then attempted to do it again. So I can actually change the code real quick to modify that. We're going a little off script, but that's what happens. Start to close. Yeah, I don't know why we're doing 10 minutes. Let's give it. It's because it's a Docker upload, and there's no like. Let's give it 3 minutes and pray. Um, we are literally doing this live now. So let's kill that old one. Actually, we can start the new one because this is using unique IDs. There's no reason for this. Go away, shoo. So now what I can do, I don't have a worker running, so that's fun. So if you don't have a worker running and you request the execution, nothing will happen because there's no worker running, no one to process the execution. I come back over here, I start my workers, and now my worker is running, and essentially now things will start to actually run. So now we're building the Docker image. Hopefully all of these things can happen in 3 minutes. So now we're pushing it to the registry. So now I can kill it. Hopefully that didn't complete immediately. It did not. Okay, so now we have to wait about 3 minutes for this to time out. But I've got a feeling if I don't give it at least a minimum of 3 minutes, then the registry push is just not going to work. Because it just depends on how it wants to be that day. So, are there any questions so far, or anything that you'd like me to explain, go more into detail about? Feel free to type them in the chat, or anything that you'd like me to recover while we're waiting for 3 minutes on this thing to fail. Can you search through the inputs and outputs? Oh, great question. So can I search through the inputs and outputs in the Temporal CLI or in the Temporal Web UI? I'm not sure if I can search through them. Like, I don't know if that functionality is built into the Web UI, but what this is just an event history. So what it does is you can download the entire event history as a JSON blob. And then if you needed to actually be able to like do an audit process of this, like if you wanted to do automated auditing, like I'm showing off the web UI because it is like a really useful tool for just like auditing in general. Um, but if you needed to be able to do this automatically, you would then what you would do is you would download the event history from each individual workflow execution, and you would then probably parse it with something to see what was going on there. We do have 3 minutes. Yes, come on, just fail and get to it. And then question, is Temporal an alternative to a CI/CD pipeline? No, Temporal is a durable execution platform. It is a programming paradigm. It's greater. There's really not a lot of other things I can really compare it to. It is a new category of tooling that allows you to build resilient software. So we are building a CI/CD pipeline for the sake of this demo because I think that it's a neat thing to build. Um, yeah, I guess I don't know how long 3 minutes is. Um, but it is like we could have built anything. My colleague Cornelia did another temporal workshop earlier this week, where she did one with using it to automate Terraform. And I think essentially like you could keep the Terraform state here inside of this event history because this event history is persisted by the temporal service into a database. So you could do that if you wanted to. Um, like I built temporal applications that do AI, like that do generative AI stuff, or they're building agentic agents. There are people who are using temporal for backend services, resiliency, order management systems, all sorts of things. So it's not a CI/CD pipeline in particular. It is a programming paradigm, and we're just implementing something in it. There we go. Now we're failing. Lord, that took forever. So what it's going to do is it has a retry policy. It's going to back off for 2 seconds, and I actually need to start this now. Because otherwise I have a maximum retry of 5. So every 2 seconds, it's going to do 5 attempts, and for 1 second for maximum interval 60 seconds. So it's going to wait a second, then it'll wait 2 seconds, then it'll wait 4 seconds, then 8 seconds, and after 5 of those times, it will eventually stop. So we now have restarted our worker. So if we refresh this now, we might be in pending again. Good. It completed successfully. So we didn't even have to worry about it. Like again, like normally, like all of this code, like when an application fails in the middle, this is a single workflow, by the way. Like this is nothing. I'm getting a little bit ahead of myself in the code, but this is a single workflow. Like this is like starting the Docker test, building the Docker image, testing the Docker, and then uploading it. We is down here, push to registry right here. So what we did with this, where is my browser? Here it is. There it is. Basically, the worker went down. So you can basically imagine that as like a simulation of like, oh, the worker went down, something broke, something died randomly. Normally you'd have to plan for all that. You'd be backing things up to databases and pulling it back down and all of that. In Temporal, you don't have to do that. The state is maintained by the application. It automatically recovered for us. We just restarted the worker and boom, now we're deployed into Kubernetes. And we're probably on the same IP address because our staging environment is woefully under provisioned. But yeah, so now what I can do, because this is that, so that was technically like demo 1. I wasn't going to show the resiliency stuff there yet, but hey, we get ahead of ourselves because it's fun to talk about. What I do have here now is I can add another flag to this. No, it's fine. We'll let it do what it wants to do. If I can't type, I don't deserve to be here. Okay, slash. This is going to be fun to figure out. I don't even need the slash. I can just type it at the end. This is what happens when you copy paste things from here. -env equals production. There we go. That's the one we want. So all these workflows over here, you two can go away. We don't need you. Shoo. Okay, so now we have one that we want to actually get into production. Did you terminate? You terminated. Oh boy. Something's upset with me now. I probably had 2 things running at the. Okay, you know what? I'm running a single threaded stuff on my own local machine. It probably did not like the fact that there were other people using the Docker at the same time. So let's see if that has resolved it. Yeah, okay. Other people were using the Docker daemon on my machine. In reality, if you were running this in production, you would have this like you would have these CI/CD builders building Docker images, and there'd be a worker with its own Docker image. And basically, Temporal ensures that only one worker gets the task and stuff. But again, because I'm running this in like a weird testing environment on my machine, it kind of messed up a little bit. So now we're pushing to our registry again. And I'm basically every time I'm forcing it to do all of this, every step, every single time. Like I'm forcing it to do a full Docker rebuild every time, because I might decide to update something and then it decides, oh, I don't want to do that because I cached it because I changed the code and it doesn't detect that the code change happened in Docker. So I like everything's happening here. But now we have an approval request. Okay, so we're sitting in Kubernetes, and now there's an approval request. And if I go and look at my code, I actually logged it out here. But now we're waiting on an approval. So this is how we get the human in the loop part of Temporal. So Temporal enables uh basically, sorry, I saw a question come up and I got distracted. I'll answer the question in a second. Enables a human in the loop interaction. So basically, I can send in signals into my temporal workflow and decide how I want to deal with it. So that's what we're going to do is we're actually going to approve this application and we're going to come here and we're going to paste it. Okay, so we've approved that, hey, this did not break production, or staging at least. So now we've approved it and now we've logged that decision and we've now deployed it to Kubernetes. Okay, great. So now let's look at our Kubernetes address. It's HTTPS, and I've got the output here is wrong. Now let's see if this is actually like, I've been having a really fun time with Chrome, like hating these automatic HTTPS redirects lately. Okay, that did work because the this updated. Yeah. Yeah, so as you can see, that's how I made sure I wasn't lying to you and not like dealing with caching is because I made sure that the host name stuff worked. Um, so yeah, our production cluster is up and running. I did not take the time to secure this with HTTPS. I only do so much. But now we have now basically implemented a human in the loop thing with Temporal, and it was super like, and as I'll show you in a second, it's super easy. You basically just say, hey, just send this signal and then collect it and do what you want with it. Now, there's a question in the chat of, can I orchestrate CI/CD pipelines through remote execution? Um, I'm not entirely certain what that means. So a clarification would be there. So all of this stuff is like Temporal is 100% like it's basically distributed systems as a service. So you can do remote whatever you want. The fun thing I always say about Temporal is it's code. Okay, people always come up to me whenever I work at booths, whenever I do these workshops, they're like, well, can I do this with Temporal? Can I do that with Temporal? My answer is always the same. My answer is, can you write the code that does that? If you can write the code that does that, then you can do it in Temporal. Plain Jane. Like there's no limitations. This is just Go code. This is just Go. If you can write the code in Go, then you can do it. That's one of the I think one of the major benefits of it not being DSL based or stuff, is that you can just do whatever you want with it and it just works. Um, Now there are like a handful of use cases in Temporal that don't necessarily play as nicely, or you have to do some really special things for. Currently, real-time streaming requires like some like really special fine tuning of temporal because as you can imagine, as you can see, like every single time that something is executed, we're basically taking a network tax and we're sending something back and forth to the server back and forth. Now, this network tax is super minimal. This is like protobufs and like a handful of bytes, maybe even some kilobytes. Like it's not a lot, so people always wonder, well, is my performance greatly going to degrade? There are very large scale companies using this to great effect. And don't worry about that latency buffer. So you're fine. And we'll talk about who's using this later because there's a slide at the end of my things of like who's using it. But yeah, so that was demo number 2. And now we're going to actually go in and talk about how this stuff was implemented. So let me go back to my slideshow. So there are a handful of core components within Temporal that you use to build Temporal applications, and we're going to go through them one by one. So there's workflows and activities. Then we have our workers, task queues, signals, our durable timers, and the temporal service. So we're going to cover all of these, and you're going to see demonstrations of all of these today during today's workshop. So let's start with the first one, which is workflows. Workflows are the steps of your process. I've also recently heard this referred to as the main program, like your Java main program or something. That's a great way of thinking about it. It's the entry point into your application. It can maintain state even after a crash. It sleeps and it can receive the incoming messages. We just saw it receive incoming signals, so it can receive incoming messages and process them as it needs to. You can run them and keep running them for years, even surviving infrastructure failure. This one of the really interesting things is Temporal supports these long running workflows with no added benefit. So when I was in SRE, we managed a platform as a service for a company. And basically, like we were doing stateless, microservices. And at the time, I mean, this was like I've been in DevRel since 2019, so this was like 2017, like 2016 to 2018. Stateful microservices were like the white whale, like it was so difficult to build out a platform for a group of people, that were doing stateful architecture. Temporal basically gives you stateful for free because of it, and because it maintains the state, your application can basically sleep forever, and then we'll just ensure that we reschedule it whenever it's time for it to come back online and execute. And we'll see that here in a second. And it's written in the code in the programming language of your choice. So as long as we support the SDK, which I mean, we currently have Java, Go, Python, TypeScript, .NET, PHP, and there's a Ruby SDK coming. And then there will be one more SDK of a very popular language that you could probably guess if you go dig around a little bit. Just go look at our GitHub repo or GitHub work. So we have our workflows, and within our workflows, we have activities. Activities are the units of work. These are used for things that we say typically are meant to fail. Those are used for calling remote services. You use this for things like processing files, sending an email, writing, making a call to a microservice. That's what you typically use these for. They're also written in the programming language of your choice, so it doesn't, just again, all code based. There's some rules for workflows and activities that you need to be familiar with. So one, workflow code must be deterministic so that Temporal can replay it and rebuild the state when it is needed. So that's super important. Workflows have to be deterministic. And you're like, well, what? There's a lot of non-deterministic code in the world. Yes, that is what activities are for. Okay, whenever you have a non-deterministic operation, such as calling out to a microservice, writing to a database, things of that nature, that is when you put them inside of an activity, which is, you can think of an activity as a function call. And those are the things that we actually saw that we're retrying. So if we go back and look real quick at our workflow event history, everything we have in here, all these little green lines, these are activities that are being run because these are potentially non-deterministic calls. They may work, they may come back, there's not deterministic. And they retry by default. So whenever we saw earlier, whenever I intentionally killed our push to registry in one of my previous workflow executions, that automatically like retried and came back online because that's how they're designed to do. But one thing we do say about your activities is that they do need to be idempotent. So because they can fail, they can be rerun. So an idempotency gets put on you. So you have to make sure that you develop your activities and your method calls with idempotency. Essentially, like these are all good practices of building distributed systems anyway, and now you just have to kind of do them with Temporal. So workflows help you build durable apps. So the workflow code orchestrates the execution of your activities and it persists the results. Again, if we go back and look at this here, we can see the inputs and outputs of every single activity after it's run. So we don't have to worry about it running, or we don't have to worry about running it again. We have the input and output. This is not just for visibility purposes. In reality, Temporal was never designed to be a visibility tool. It just so happens that having basically an event-sourced event history makes for a great visibility tool, and people do really like it. If an activity fails, the workflow runs again by default. And if the application crashes, Temporal will automatically recreate it to the pre-failure state so it can continue right where it left off. So if a workflow does crash, say you have a workflow that has 10 steps in it, it crashes on step 5. Normally, with a normal application, you'd have to start over at the very beginning and re-execute all your code. With Temporal, because we persist the state of the activities, it basically reconstructs the state. It will reassign the value that was like assigned, that when that function call, that activity executed and assigned it to a variable, it will go read the result, the return value out of the event history and reassign it. So it rebuilds it without re-executing all of these activities. And then once it gets to that point, it just continues onward as if the failure never happened. So the next thing we have are the workers. So workers execute the workflow and activity code. So the execution of code in Temporal is indirect. You never the code you write is the code that runs, but you don't just work like Python workflow or Go run workflow.p or workflow.go. I keep doing Python in my head. That's not how they run. Basically, you request the execution of the Temporal service, and the Temporal service will then basically find a way to schedule it, and then a worker executes it. So the workers execute your workflow and your activity code. These run on your own servers. You are responsible for running your workers all the time. Um, so again, like Temporal does have a cloud offering, we are open source, but the cloud offering is just that temporal service. It's not the execution of the workers itself. You are always there for that. And there's a lot of benefits for it: security, data, privacy, all that. You deploy them like you would deploy any other application. It's just a Go program. How do you normally deploy it? You compile it, put it in a Docker container, run it to Kubernetes. Fine, works great for me. It's all they have to do. Run it like you would any other application in your infrastructure. How do they communicate though? How does the worker know when to pick up and run things? This is done via task queues. So when a temporal client starts a workflow, it starts it by basically adding the workflow request to a task queue. These workers continually poll these task queues for work to perform. As the worker encounters this work to perform, whether it's workflows, whether it's activities, all the stuff, these get added in the task queue and the worker consumes them. And what happens is it executes this code. So once you get multiple, what you can do is multiple workers can watch on a single task queue. So this makes the scaling story of Temporal super simple, because if you have a lot of requests coming in for this one workflow on this task queue, the way that you scale Temporal is just by scaling up the worker fleet and allowing more workers to execute it. Workers don't pull, or like work in Temporal is not pushed down, it's pulled. It's a pull out. So the only security thing you ever have to worry about is a worker pulls outward and you have to open an outbound connection from the temporal worker to the temporal service. Um, so you scale all these up, and now you have more workers polling on these task queues, and they can pick up the tasks as they need to be executed, execute them, return the results back to the temporal service, which will in turn return it back to the person who invoked it, and that's how the results happen. So Temporal, the scaling story on Temporal is super simplistic. Like you don't have to worry about routing all these different requests into load balancers and stuff, because, or at least on the worker side, because you have the task queue. Now, if you self-host and run the temporal service, you will have to eventually load balance to the temporal service. If you run Temporal Cloud, that's handled for you. So now we have signals. So signals communicate with your workflow. So they basically allow you to send data to a workflow. We were sending an approval message, as you saw earlier. So we approved that this application was not breaking staging, so we approved it to go to production. And workflows will receive them and make decisions. And what you can do is you can block waiting for a signal, or you can choose to just, like, if the signal comes in time, accept it, whatever you want to do. We were blocking waiting on that signal, but you could have an application. Say you had what's one that we've seen that we have a demo of. So you have an order management process, or someone, like, orders something, and then, like, it's going to the, like, they've been billed and it's going to go through the shipping, and they have a 3-hour window to cancel the order, for example. You can basically implement that as a signal, where the signal comes in, and if we receive that signal within those 3 hours, great. We can make the path. But if after we get to that point, if they haven't done it within that point in time, sorry, like the thing's on the truck, we can't refund you at this point in time. You have to go through a different process, or we can't cancel the order. Refunds will be later. We have to go through that at a different point in time. So kind of like that with CI/CD as well. And its counterpart is query. So there's signals and there's also queries. So queries is a way to get data out of a workflow. So if you have data that, like, so say you have like instance variables, or like you want to know, like, what is the status of something, you can basically set up variables and then do a query on them and get the value out of that and return it back. So you can constantly be checking in and saying, like, hey, what is the status of this? Like, why is this build taking so long? Oh, it's stuck on this. You can query into your workflow and get introspection into what is happening. And then finally, we have timers. Timers pause the execution of your workflow. You can sleep for minutes, days, even years, and you do this basically by running like a timer, like in Python, it's like sleep.30, like, time delta 30 days or something. Now, in normal programming code, nobody would ever actually write that, because you wouldn't expect it to actually run, because we all know what happens when an EC2 instance just magically disappears. Been there, done that. Like they just happen. Like you just lose cloud instances on occasion. And now we have to reschedule it. But the thing about Temporal is that these timers are guaranteed to fire always. They are managed by the temporal service, and they don't waste any resources. So what happens is when the timer is set, it's managed by the temporal service, and then the worker actually deschedules the workflow. So like the workflow that was running, that was, like, taking up some processing power, gets descheduled. and it just sits there. So if you sleep for 30 days, it's not sitting there holding up a CPU thread, wasting resources. It's like, oh, okay, whenever this thing fires, I will resume execution because Temporal can reconstruct the state. Because we have the ability to rebuild that state, we can now just, oh, we'll just stop. We just stop execution, and we can don't have to worry about the timers anymore. We have essentially virtualized execution, if you think about it. um, Execution is no longer bound to the process or the machine that is being run in. It is virtualized execution. It can be run anywhere, we can recover it anywhere, and it can run across anything. And then finally, the temporal service. This is the heart of it all. This is what manages all of the execution of your workflows and your activities using task queues. So as your app completes tasks, your app will add events to the event history on the service. This is a much more complex thing that I'm leading it on to be, and I usually teach like in depth about this, but I don't have time today. So, but it's a really fun topic. So ask me questions about it if you want to know. And it makes all these things happen, and the connections are always only outbound. You do not need to worry about. Temporal does not need access to your network. Phew. Does anyone else have any questions? I'm going to take a drink of water. Is Temporal a project from the CNCF? No, Temporal is not a project from the CNCF. Temporal, there's actually a really neat history of Temporal. So Temporal is built by two founders who essentially built out a lot of different tooling in their career. So let's see if I can get this top right off the top of my head. Um, you know what? We're gonna go and I always forget which AWS service it is. Um, but there is right here. Yeah, so our founders basically started working together at Amazon in 2004, building Amazon's messaging infrastructure, which became the foundation of Amazon SQS. So they were some of the original people that built Amazon SQS. Eventually, one of the founders left and then went to Microsoft and built out what would become the foundations for Azure's for Azure Durable Task Framework. Also, while they were at Amazon together, they built out Amazon's Simple Workflow Service. So they built out what became SQS, and then they built out the first public version of Simple Workflow Service at Amazon. Then one of the founders left and went to build at Microsoft, and then the other founder continued to build tools like Amazon Flow Framework. So that stayed. They continued building that at Amazon. Then they both reunited at Uber to co-create Uber's Cadence. And then what happened is Cadence was forked. They were given a blessing from Uber to fork Cadence into Temporal. So basically, Cadence had already been running, I think, for like 4 or 5 years at that point. Like it was already a project. They had open sourced it. It was basically running all of the stuff inside of Uber. Um, and then they forked Cadence to become Temporal, and now we have like 6-ish, going on 7-ish years of Temporal service. So this was already like this has been an open source project, like in and of its own workings for almost 10 years now. Um, Different names. But yeah, so it's not a CNCF project, but it is like a super open source project that like our founders are dedicated. It's MIT licensed, by the way. I don't know if I mentioned that. It is all of it is MIT licensed minus the Java SDK. Because the Java SDK has a dependency further up the dependency tree, which is Apache 2. And if you know anything about open source licensing, you can't downgrade licenses. Um, so that one's stuck with that. But it's not just open core. What the service you run in Temporal Cloud, the features are what you get in the open source. What Temporal Cloud offers is that we offer you're gonna have better performance because we have a custom persistence layer underneath the hood. And there's also a lot of the production features. So if you want Lord, what I cannot think. I just had a brain fart. Access control, like yeah, access control for oh my gosh, IAM, for acronyms since it's early, for everything, and then there's other like SCIM and stuff like that. That's all in Temporal Cloud as well. That stuff's not built into the foundational product, but the actual functionality of the open source project is all there. So Good question. Next. This is just an interesting little application of what it looks like. So a request would come in, go to the web server via gRPC to the temporal service, and then you have a temporal backend, which the gRPC service goes to the client and the worker and runs your code. So what happens when you run a workflow? The workflow gets scheduled to run and a worker picks it up, creating what's known as a workflow execution. The worker executes the workflow, it executes local code and activities, and the results of those activity executions are stored in the workflow executions event history, and any failed executions are retried until success. So what makes workflow temporal applications durable? In a crash, the workflow is rerun, rebuilding the state by replaying the event history and rebuilding the workflow state. Previously completed activities, as I said earlier, do not rerun. So you just use the result that was stored and to rebuild the application state. When the state is rebuilt, the workflow execution resumes, and we go on from there. So now we can move back on to the last two parts of our demo. I'm getting through this a little bit quicker than I thought I would, but knowing me, I can talk about stuff forever, so we'll be fine. Cool. If anyone else at any point has any questions, let me know. What did I change? Did I? Ow, yeah. Probably not a bad thing to, we'll back that out for now. I cannot type. Okay. So now we'll start the worker again, and we'll start another execution again. So we go back to our web UI, and as we can see, we have one running. So we built our Docker image, we're testing our Docker image, it's being pushed back up to our repository. Again, I've manually forced this every single time just for law of live demos. Always fun. As we can see, it's taking its time. Okay, so now we're deploying to Kubernetes, and now we're waiting on the approval request. We go back over here, and we grab our approval request. We approve it. So now what's going to happen is it's going to deploy to Kubernetes, but now what we have implemented is we've now implemented a timer. So what this is a durable timer. And after 30 seconds, if nobody sends another signal saying we approve of this, by default, it's actually going to roll back our production settings. So right now we have our code at 208.38. So this is running. And did I not hit it in time? Boop. Yeah. I cannot find all of my, I don't need the Excel draw anymore. Okay, so now we've rolled back the deployment. Let's go back over here. This is easy. Like, I need to stop using the browser and just use my HTTP. So it's 209. And as you can see, it's not going to work because we've rolled back the deployment. I think someone had a question. I swear I saw a question about observability. How can you monitor temporal workflows? No, good questions. There's great questions coming in. So what happens to running workflows if you deploy a new version? This is a fun one. So if you have running workflows and you deploy a new version and you have made changes to the order of in which these activities happen, that will create what's known as a non-deterministic error. You have now changed you have changed temporal's ability to reconstruct the state. There are strategies around this. There's what we call versioning. So there's two different versioning strategies, or there's a handful of them, but there's two major ones. There's what we call patch versioning, which basically is kind of like, you could think of it kind of similar to feature flag versioning inside of a code base, where basically you say all of my old versions take this path, all of the new versions will take this path, and you basically wrap them in like an if statement, like if it's the old version, do this, if it's the new state version, do this. Because if you do deploy a new version while there are currently running workflows of that same type running, and that workflow has to do a reconstruct of itself, and there's nothing there doing it, it will break. Basically the non-deterministic error, and then you have to go in and back that out and fix it. So that it is something you have to take care of, but it is a totally solvable problem with versioning. That's patch versioning. Now there's also something else called what we're calling worker versioning or safe deploys. And essentially what this is instead is basically allowing your workflows to, excuse me, basically blue-green deploy, where you can have all the new versions routed to a new version of the worker, and basically and the workers, all new executions will go through that, all the old ones will go through the older version. And essentially what will happen is once you are certain that the old version has gone offline, you can then decommission those workers and stuff. This is a little bit more tricky than it looks, because it's not just when the workflows are running that it matters that you have this versioning. If you ever plan on querying these workflows after they have closed, you need a running worker that has the version that ran when they were running, because a query does trigger a workflow replay. Now there is something in Temporal what's known as the retention period. Um, Basically, how long do you keep things with inside the Temporal web UI? And like that's usually set to like 7 days or something. That's basically after the workflow has completed. Um, and after that point, so that kind of informs that strategy. It's like, okay, if everything is gone and we are no longer within a retention period and nothing, we can never query it again. Now we can decommission it, which is totally fine. And at that point, just download the event history as JSON and do your own querying on it. Like do your own like parsing of it. Um, Querying is great for like getting out what's going on live, but like if you need to do like actual business analytics on it, do like something with that. And then there's another question about how can we monitor temporal workflows? The way you would monitor any other application. So we have a Datadog integration. There's also new I think I don't know if there's a New Relic integration yet. Um, I don't remember, but you would use a normal like APM tool or something, or like an alert system or like a logging system or something like that. So you would monitor them like you would a normal application. We do have our own custom metrics. So like if you're trying to worry about like how do I know if I have enough workers and there's not enough, like how do I know if there's so many requests coming in and my workers can't handle the load? We have custom metrics for that we emit. And I believe it's open telemetry, so you should be able to just ingest them as any way that you want. So you should be able to do that. So you can monitor them the way you would monitor normal applications. It should just slot right into your stack, relatively straightforward. I very rarely ever hear of anybody complaining about like the monitoring story here. Um, good questions. Let's run this again and let's actually like like hit the actually hit the approval this time. It means I have to be fast. I only gave it 30 seconds. I probably should give it a minute. You should have like Jeopardy music playing whenever the push to registry part happens. It's the slowest part of this entire process. There we go. We're deploying into our staging environment. We have our approval, so we go back over here. We grab our approval line. We run it. And okay, so now we are waiting on that. So we should have gotten the approval log line, and I probably should like, actually put my name in here and stuff, but we're not going to do that. So now we've approved it, and what we did is we validated it, and what it did is it canceled the signal came in and it canceled the timer, and now the code should still be live here at the at 209.38118. So if we do another HTTP, as you can see, we got it running just fine. Okay, can you touch on security, auth, RBAC, policies, etc.? So that is the parts, the RBAC, that was the word. RBAC on the temporal UI and stuff, that's the stuff that is within Temporal Cloud. Now there are open source projects that allow you to add this on top of the temporal service thing. So you can think of the difference between the open source model and the cloud model is like all of the production, super production level things, all of that effort work that is going into the cloud offering, which is the paid offering essentially. Now I will tell you, just as like you can go look at our YouTube channel because we have our own user conference, which you should attend coming to if you're interested. It'll be sometime next year in spring. But there's also past videos from the conference. Um, Everybody that will ever tell you that like you will save more money by using cloud than you will by trying to on-prem host this thing. The on-prem hosting of this requires a SRE, a dedicated SRE team, and a lot of effort and a lot of just AWS resources or cloud provider resources to host it. As you can imagine, like you have to have a really resilient database. You have to have a lot of like servers. Like there's the Temporal service itself is not a single binary, or well, that's a lie. It's single binary when you deploy it, but it's like a handful of microservices you deploy in different various states. There's like 4 different services on the back end, a front end service. I'm running the Temporal CLI as a binary itself because I'm running the development server. Um, it turns out that they're all a single binary that you run and you put them in a different mode. Okay. Um, so running it self-hosted, at the end of the day, there are many people from other companies, not just me. I mean, I work for the company, so obviously I would tell you this. Go look on the channel. There are many other people that will tell you. There are case studies on our blog. There are videos that will tell you that how much money and how much more ease of life it will be if you don't go that route. But that's fine. And that's where the security settings are and stuff. The other cool thing about the security settings is you control the keys of all encryption. So, like as I said earlier, the workers run in your environment. Now, the interesting thing about all of this is that the data that is sent back and forth between the worker and the temporal service is actually not encrypted by default. It is base64 encoded. And you may be going, well, why is that? Well, because if we picked a default encryption, everybody would tell us that we were wrong. So what happens is you actually implement a sidecar. This is super well documented. It's part of the production to go into production story. You implement this sidecar application, which is a basically a temporal like base off and off and not off, sorry, encrypt and decrypt endpoints, and then you control the keys. So that means that all this data that would be coming in right here would be coming in like without the server to decode it. You would see this all as encrypted binary blob data within this local host within this server right here. You wouldn't be able to read it at all, and you actually configure that up here. What's called a codec server. Excuse me. So that's part of that's the security story. So the security story on like how do you protect your data is you own the keys, you own the rotation policy. We don't care about your data. We care about the events like this, like the timing. When does this timer need to fire? All of this stuff. Like we don't care about the data that's inside of it. When it comes to what the data is, there are size limits on how much data you can send within the event history. Obviously, like if you start making this event history really large, its ability to stream it and reconstruct it becomes an issue. And again, this is covered in our documentation and our courses as well. We have a whole bunch of free courses that we built that I helped build. That's part of my job. So yeah, that's a little bit on the security policy stuff. I hope that answered your questions. If you have any specific things, I can answer, but I hope that covered it. So, yeah, that is the workflow for this part. And this is basically all of these are the nifty features part. Now, there's a last part that I have to cover. And it looks like I'm going to probably end a little early, but that's not terrible, I guess. I can always just answer more questions or just keep throwing out demos. I've got demos for days. Check out part 4. So polyglot. So under the hood, and I actually need way more TMUX terminals for this. There we go. Under the hood, all the communication that happens between all of these applications is done via gRPC. We always say in Temporal, your activity inputs and outputs and your workflow inputs and outputs need to be serializable. Like that's a requirement. And the reason this is because they are put into protobufs. And what this allows everything to be natively polyglot. So what application 4 does, or what part 4 does, is it allows us to essentially write our activities in different programming languages, but still call them from a Go workflow. So I'm actually going to show you this because I just realized that I've not shown you any code, which is super rude of me, because it's all right here. It's also in the GitHub repository, so you totally could have been looking at it yourself. But like, so just a quick rundown. This is our workflow, the CI/CD pipeline workflow. This is how we read in what's going to happen. We set our activity options. This is our retry policy stuff that I was talking to you about. Our activity options for this specific one. We are setting. We didn't need to set it for all 3. Oh no, because these are the TypeScript ones. Okay, now we're in the weird part. I guess you didn't have to do it that way. Yeah, interesting. Yeah, I wrote this a while back, so I don't remember what I did. So, as you can see here, execute build Docker image. And then we're building our Docker image. This is just executing the activities, testing the Docker container, push to registry, Share dot. But now you're going to see here, we'll see this one's into a string called deploy to Kubernetes. So what this is now is we don't like we're doing this politely here by like we're referencing it as we would like a Go module or actually a it's actually a public method is what it is. Um, and what we're doing now is you can also always refer to them by like their string representation, like their workflow type. Because of this, they can be polyglot. This one's actually going to be written in Python. And we're going to run what I have done is I have implemented. So we originally had our workflow and then we have our activities. And our original activities were all the approval activities, which is like send the approval request, log the approval decision, and then this send approval notification, which I never actually ended up using. Then there's the Docker stuff, which is building the Docker, and the Kubernetes deployment activities. I made 3 different activities files. What I've done now is I have implemented the Kubernetes ones as Python right here. So all of our Kubernetes all of our activities now are written in Python, and our approval activities are all now written in TypeScript. So all the approval stuff. So we're going to have a program that is natively written in 3 different programming languages, and in the workflow itself, all I have to do is write them as I would almost normal looking code. And because Temporal handles all of the communication layer, it just natively happens. So let's go ahead and demo this. Okay, go run main.go. And now I need to change directories into my TypeScript activities. npm run build. Did I do that wrong? I'm so bad at TypeScript, it's not even funny. npm install. This is the language I do not know. npm run build. There we go. npm start. Okay, now we have our TypeScript worker running. And now let's go into our Python, UV sync. Do I need to sync right now? Yeah. And then UV run. I guess I could have just done a UV run. It wouldn't have mattered. Worker. Okay. So now we have 3 workers running. And now the interesting thing is they all have to be listening on different task queues. So you'll see, may have seen in the original pipeline code, pipeline.go, in our, where we were initializing this up here. The Python ones are on a different task queue. If you have them running in different programming languages, they have to be on different task queues. So workflows and activities don't have to run on the same workers. They don't have to run on the same task queues. So this is really, again, we've virtualized execution. Do you want to run all of your functions on one machine but you have one function that needs a GPU and you want it to run on another machine? Fine, do that. Or you use a task queue, use a separate task queue for the execution of that activity, only deploy those workers to that type of machine, and then have it run over there. Works just fine. Kind of neat. If I didn't like this so much, I wouldn't do it. I think this is by far probably some of the coolest technology I think I've ever worked with in my life. So now we just run it the exact same way we've been running it. And now it's running. Let me come over here, go back to running. We're pushing to our registry. I have this really cool toy on my desk. It's called Ball of Wax, and it's magnetic. It's like that, but you can take it apart and build things out of it. You're supposed to build things out of it. They encourage you to like build. I've never actually built anything out of it. I always just put it back together. Okay, good. We're done. I don't know what to do during the long, awkward silences. Okay, so send the approval request. Now let's look at this though. So like deploy to Kubernetes. So if we look at this, we look at our, okay, CI/CD task queue go, but let's look at deploy to Kubernetes. Ooh, CI/CD task queue Python. So if we go to our Python worker, we can see that this was where we ran a Python worker. The deployment options happen in Python. So, and now this is our TypeScript worker. We can see this is very TypeScripty. This is Go. The approval stuff is happening in TypeScript. So I copy that, and now we approve it. Ah, I did it again. I always never grab that see, I did it. Like, see how I'm doing? I'm not grabbing the last letter, the last number. I've done this like 4 times. There we go. Now we've approved it. Now we need to go back to the Go one because again, I only have 30 seconds. Actually, you know what? I'm just gonna let it. I'm gonna let it time out. But now we're back to Go, and our validation timer's in Go. And we will validate it. We'll let it. We'll be nice. We'll say that didn't break production, and we validated it, and we're good. So that all ran. If you look through all these, you can look by like you normally there's does it say within a way of looking at it to actually I'm curious if it actually tells me what SDK it ran on. I can tell because you can tell that it's running based on the task queue name. And because we can see the logs in the worker, but I'm curious if it actually tells me what SDK it's running within. Whenever it fails, part of the protobuf message will tell you what SDK failure it is in, but it doesn't tell me that in here. I don't see it. Which is fine. I mean, it doesn't need to tell me. This is really irrelevant data if it's not overly important. Okay, so that is it running in production, and our 209 should still work. So let's run an HTTP. Boop, we're good. So that is polyglot support for Temporal. Any questions? Use double-click text in terminals. If you set your word separator correctly, it's very easy to use unless eye straining. Oh, I can use triple click, can't I? I think that's what Brendan Rhodes taught me. And then once I do that, yeah, because in Tmux it automatically does. Yay! Hooray! Thank you. Any questions before I move on to the final little closing bits? We're actually going to end this about relatively on time. Which part about security do you want to know about? Because I touched about it a little bit on the codec server stuff. If anyone has any specific security questions, I will happily answer them. But like, I would like to know which other parts you'd like me. Using sensitive strings and workflows data. Fantastic, easy enough. Okay. So you control the codec server. Let's go look at it. Docs. Codec. So this is how codecs work in Temporal. So again, like I said, Temporal does not encrypt data by default. You are responsible to implement this. Yes, there will be a recording afterwards. And also, I will show you all the cool places where you can learn all about this. So Temporal has basically, there's what's called a codec server. And what you do is you implement a sidecar that runs alongside your Temporal service. And basically by you, I mean, like if you're running this self-hosted, you run this as like your ops team who's running this runs this. Or even, this is an ops team thing. This is not something that every team needs to run. And what happens is that all traffic gets routed through an encrypt and a decrypt method. So like when it goes to Temporal, it gets encrypted, and when it comes back to you so you can view it in the web UI, it goes to the decrypt method. And at that point, you are responsible for the encryption and the decryption. So you basically encode. So let's look at a Go version of this. Codec server or data converter here. So this is the encode data converter looks like it's using Snappy. So this isn't even encryption. This is using this is using Snappy, which is a compression, but it's the same thing. Same sidecar along the actually no, sidecar you would use a sidecar along for my use case, I am just using a starter from the CLI. It would be a sidecar along the worker. Yes. So, or actually, it could really be anywhere because you point to it via a URL in the when you run it. So let's look at the worker. So when you run the worker, what you do is you basically specify. Actually, you specify the data converter within the same directory as the here. You know what? This is why we have GitHub, because I can just drop you the exact sample code in Go on how to do it. So you basically have the codec server, and then you control all the encryption. So right now, this sample is using Snappy. That's not encryption, that's compression, because it's the same thing though. Like we didn't want to like set up keys, and if you upload keys to GitHub, they get wildly upset about it. Haha. Yeah, this is currently doing compression, but it's the same thing. It's not the same thing. It's the same implementation, just replace Snappy with like whatever you want to do inside this encode decode method. But this is the exact implementation of how you would do it. You are responsible for it. And that basically, and people love this model. Like, I mean, people originally look at me like, what do you mean you don't encrypt and decrypt by default? Well, yeah, because then I have to worry about all of your SOC 2 things and like, what is your, like, are you FedRAMP or not? Like, what is it like? What are your requirements for security? Do you have someone who got wronged one time by someone on the internet and now everything is a freaking 8192 SSH key? Like, that becomes a thing. So like, what level of what level of security and insecurity do you have? You get to implement it. And I think it's a brilliant model for it. So yeah, you control it, and then that basically ensures that whatever data you send, sensitive data back and forth, you control the encryption. And then if it gets leaked, that's on you. It's not on me. Um, yep, exactly. So what this does is that the temporal UI will not see this data. Like the data that goes into the temporal UI, like, so if you encrypted the codec data with it, like, so let's go to the temporal UI. I wish I had do I have a running sample of, let me check. I might have, I was working on this course recently. I might have a demo here. Ah, I don't have my demo right now. I guess I tend to remove things from my um stuff. So there is a course. I'll literally just go to it right now. This gets to kind of the end of what I was going to anyway. So Temporal has a whole bunch of free courses that teach you how to do everything you want to do in Temporal, one of which is the Securing Application Data course, which has step-by-step exercises to show you exactly how to do the custom data conversion, how to do the codec server. What happens in the web UI is if you do the data conversion with the encode, and you don't, there's what's called the data converter, which will do the encryption, and then there's what's called the codec server. Okay, the data converter will automatically do the conversion, and then only you and the workflows can read it. But then the web UI will just be jumbled garbage. Then you create what's called a codec server, which is actually, yeah, I did mix it up in my head a little bit, which is the sidecar, which implements the encode and decode, which allows for you in the web UI to see it. Then what you do is you basically say, hey, here is where those endpoints live, so I can read it in the web UI. You can do the data converter implementation in the workflows, and then nobody but the workflows will ever be able to read the data. You won't be able to read it from the CLI. You won't be able to read it from anything. Only the workflows will be able to read it. But if you would ever like to be able to read it, which, I mean, that's kind of like, limiting yourself because you want to be able to read it, that's when you do the codec server, which uses the same implementation, and you link it to your web UI in Temporal Cloud or in the local host, and then that basically will decrypt it on the web UI for you because it's basically using endpoints that know how to use your data converter. That's what happens with it. Awesome. I am teaching. I love it. And the other thing that I didn't really, I mean, the temporal service as well, like workflow. Do I have any workflow shows in my? What's the workflow ID? You have the web UI, but you also have the CLI, which allows you to see this as well. I mean, this doesn't really give you too terribly much, but you can do detailed, and it gives you a lot. So your web CLI does a lot with it as well. Um, cool. I think that was all the questions that I saw come in. Cool. Let's go ahead and do the last handful of slides, and we're going to finish up right on time. So going to production. As I've said multiple times, Temporal does not run your code. It's just the orchestrator. You run the workers. You deploy your Temporal application as you would any other application. You scale the workers to meet the needs of whatever you have, and you have outbound connections over TCP 7233. A production temporal service, there's two versions. There's the self-hosted option, which is an MIT license. You scale it as needed. There are Helm charts available if you want to deploy it. We do more often, 95% of the time, people are deploying this into Kubernetes, and that number is probably higher. So we have Helm charts to get this going. There are Docker Compose repositories, which you know what, because I'm just feeling super nice with my stuff, and because I can actually drop links to people for once, which is nice. Temporal IO/Docker Compose. So if you want to run the local version of this, you can run Docker Compose. You can also run Helm charts if you want to self-host, or you can run Temporal Cloud. So the so basically, I always do brew install Temporal. There's the Temporal CLI. Is it called Temporal CLI? It is. It's just called CLI. This is what I use for local development. Now, before the temporal CLI existed, Docker Compose was pretty much the only way to do it. You can still do it if you want. That gives you, the ability to kind of like look at the microservices that are running underneath the hood of the temporal service, tweak them, do a whole bunch of fun things. Um, if that's your cup of tea, do it. I've been working here for 2.5 years. I've made courses on and done so many advanced temporal things. I very rarely ever have needed to drop into the Docker Compose. That CLI is a load bearing. We call it the dev server. It's a load bearing. That's a load bearing name. It is basically a fully functioning version of temporal. You can do dash dash db or db-file name and basically run it on a SQLite database, and you could probably run that, like if you're doing say home projects. I run this on a home server. This is all I use. It works just fine. So for hobbyists and stuff, totally fine. um Cool. Do you have any tips for temporal workflows managing things like K8's deployments, for example, where the state of action has to constantly be pulled? Ooh, I do not I do not personally have anything off the top of my head, but I know that we have patterns around polling. Let me see if there's anything in the docs. There is confirm polling worker. Maybe it's in here. Um, No, there is something about that with polling. I've seen it before, and I hear about it all the time. And I think we're working on some content around that. This kind of leads to my next one of my last slides, which is how to get involved and ask questions in the community. So last slide. If you're worried about who is this so we always I like to say this is the most one of the most used open source projects you've never heard of. There's a lot of people using this. It's very well used. If you go and look and you do a little bit of research, you can find some recent articles from some very large AI companies, maybe the largest AI company, on how they're using this underneath the hood to orchestrate things. Um, it's literally they posted a blog post about it on the Pragmatic Engineer. So go read it. This is used by a lot of people. It's a fantastic tool. It's one of my favorite tools ever. Like I am honestly mildly jealous that I don't get to work and write code in this anymore because I love it. Um, and then finally, you put the wrong link here. Uno momento, por favor. Um, I mean, you should take that too. That's my GitHub repository, but there's a better link that I can give you here, which is, you know what? We'll just drop it in here. Temporal.io/community. So in the Temporal.io community page, um, you can find all of our links stuff. We have a Slack channel, a community Slack channel where all of our engineers and our founders hang out. If you have questions, go ask there. That is where, like, literally they sit there and basically run like quasi customer support all day long. You can go, there are language channels for every single SDK. Go ask questions. Like that you will get an answer probably within a day every single time. Go ask questions. Like this is, I always recommend it. I don't think enough people know about it. Go do it. You'll get all the questions you need. If you so join the Slack. We have a lot of really cool events that we do. There's a lot of good learning material. So this is the team that I am particularly on. So I'm going to plug what I do. I work on a lot of the tutorials and stuff in the courses. So Temporal has spent the last like 2.5 years building out like these courses, these self-paced free online courses on how to do different things. If you're brand new to Temporal, you can take like the 101 course is like it's great for people brand new, but I will say it's a little bit slow. 102 is like the gold standard. Like this is the course that no matter where I go, I end up teaching this course, because at least the first half of it. Because this is how you understand what's actually happening in Temporal, what's going on under the hood. This is where everybody that I've ever taught has their aha moment. They're like, oh my God, that's so cool. Like it happens in here. This is probably my favorite course that I've helped write. And then there's a whole bunch of other things. How does the error handling model work in Temporal? How does versioning work? Somebody asked about that earlier. Super important. The codex server, interacting with workflows as signals and queries and all that stuff. And then there's an introduction to Temporal Cloud, if you're curious about how all that works. We have different tutorials based on programming languages. I'm actually working on some AI tutorials right now. So check back in about a week. There's going to be some AI tutorials here. Example applications, some fun stuff. This is my favorite thing I've ever made. There's a comic that explains what Temporal does. I helped write this. So that's cute. Yeah, these are the learning resources we have available. with the cheapest essentials starting at what you do it a local host. Yes, with the cheapest essentials starting 100, you don't need temporal cloud to do our learning. Ooh, you just thank you taking a screenshot. Um, use the local host, use local development. Temporal cloud is for when you are ready to take things to production. Like it's not meant for development. Because as of right now, you're right. The yes, brew install temporal essentials is really for I have things ready to go, and I have customers paying me. Go for it. Now, once you get into it, because that's the thing is like the way temporal's pricing model works, it's based on what are called actions. Which, if you look at our temporal, let's go back and look at our UI. If we look at our UI, boo, did I break it? Did I turn it off? I turned it off. 1 second, we can redo this. And I didn't have the persistence layer on. Oh, shush. Go run. Yes, I know you're not on. Everybody on? Everybody running? Yes, there is a workflow. Oh, you don't have any workflows registered. Shush. Come on. There. Oh my gosh, I'm not right. Bleh. There. Good. Okay. Now I can show you what's going on. Never turn off your demo. Okay, so basically what an action is, the way that the billing works is anything that writes persistently to the database. So these activities, because this is writing like this data here to the database to be stored, that will be considered an action. And these are billed at like fractions of a penny. Um, so if you have large amounts of people of things that are being done, like this would be useful. Again, like this is one CI/CD pipeline for one deployment. As you can imagine, you have like a lot of these being run because you're probably deploying hundreds of these a day or thousands of these a day. So like this basically brings up the idea of what we call the entity workflow pattern, or as one of my colleagues is calling them, the digital twins. And I'm loving, like, she comes up with the most neat sayings for this stuff, and it's amazing. But yeah, so that's how that's built. So yes, do not do tutorials and stuff on Temporal Cloud. There's no do not pay me to learn. Like learn and then pay when you're ready. To when you actually have like a production use case that's worthy of paying. So yeah, as you can tell, I kind of want a lower price tier, but I understand why. Any other questions? Oh, if you would like to talk about, I'm just going to keep going down the list. If you'd like to talk about temporal in your local environment, we have this thing called Meetup in a Box, which is basically you want to go talk at a meetup about temporal. Here are some pre-built slides on every programming language, instructions on how to use them, slides and some sample code on how to demo temporal. You want to present it internally to your company. Maybe you get really cool and you're really into temporal and you don't know how to give like a brown bag on how to do temporal. This is a great place to do the great place to come get resources from brown bags on how to explain what temporal is. Learn.temporal.io. Basically, if you go to the docs page, you'll find your way to our learn site. Um, any other questions? I hope you enjoyed it. I will answer any I can this we're now at the point where Mason answers random questions about anything you'd like to know. Recommended this on frequent polling. Oh yes, let's talk about the Slack temporal bot. That's great. Um, how neat. So we have a really interesting Slack bot in our AI, which or other way around. It's in the Slack bot, but it's also in our docs as well. So you can ask in both places. It's the same place. It's something called kappa.ai. So basically what it does is it actually it's an AI that it indexes our docs, our courses, our discourse. So there also is a community discourse. So let's go to that community.temporal.io, which is not temporal.io/community. There's a discourse forum where you can ask questions. And it also indexes some of the channels in our Slack channel from things that are specifically asked that are responded to responses from our founders. But you can ask it like, how do I send a message to a workflow? And what this will do, and like unlike other AIs, which will lie to you sometimes, even though they have gotten better, this one cites its sources. It basically will tell you exactly how to do it, and then cite it, which is why we kind of like it and it's why we do it. So these are like it gives pretty good answers and then does some citations. So play around with that AI. It's really useful. We evaluated a lot of things when we like you can tell docs people are really weary of AI. So we evaluated a lot of stuff, and this is one that we actually really like. So we're proud of the fact that this does a good job. Awesome. Thank you so much for coming. I hope y'all liked it. We are kind of at time. I will stick around to the bitter end. I've got 4 minutes. If people keep having questions, I will keep answering questions. Um, and if you have anything else you'd like to know, like, again, I will answer any other questions about any other stuff. I should have thought of it using, I never think to ask AI or to ask this AI. I always forget that it exists. But it is also in the Slack, the community Slack channel as well. There's an Ask AI Slack channel in the Slack channel you can use. So you can ask it in there, or you can ask it in our docs channel. Or docs page, sorry. Anything else neat? What was on my last page? Join the community, read the docs, follow a tutorial, take a free course.